Hello friends, I am Professor ANIL BRAHMIN from Sri Sankaracharya Technical Campus, and in this video we will understand the torque in magnetic field. Whenever any current carrying coil or conductor is placed in the magnetic field, the torque is exerted on it. For that we have taken one example. Here a current carrying conductor is there, which is in the form of a coil. Say this is a current carrying coil which is placed on the XY plane, which is carrying the current of 10 amperes. If we will see the dimensions, it is having dimensions as 3 meter into 4 meter in the y direction. Now this is the magnetic field B, which is minus 0.1 AY plus 0.2 AZ, which means it is in the AY and AZ direction. Now for calculating torque exerted by this current carrying loop which is placed in this magnetic field, we can use the expression of torque as IS cross B, where IS is the magnetic moment, ampere meter square, where S is the surface area of the current carrying loop. Now here, as we have taken in this example, current is 10 ampere. Now if we see the surface area, which will be 3 into 4 meter, and now the very important thing is this inclusion of a vector AZ. If we see this surface, this is in the XY plane and current is flowing as shown in the diagram. Thus we can say if the current is flowing like this, the direction of IS, magnetic moment, will be upside. This is the direction of IS. So magnetic moment will be generated by the current, and this direction will be in the AZ direction. Because loop is in the XY plane, magnetic moment will be in the AZ direction. This is very important. Thus this IS will be equal to 10 into 3 into 4, that is 120 AZ ampere meter square. Now the torque will be IS cross B, and as we are knowing, IS cross B may be written as in the matrix form X A Y Z, because we are having for IS X component is 0, Y component is 0, and Z component is only existing, that is 120. Similarly for B, as we have seen, because B is 0.1 AY plus 0.2 AZ, X component is 0, AY component minus 0.1, AZ component plus 0.2. Now we can calculate torque as 120 AZ cross 0.1 AY plus 0.2 AZ by this matrix form also, by this directly also, as we are knowing AZ cross AZ will be equal to 0, because cross product of the same vector will be 0. And if we will see AZ cross AY, it will be minus AX. Thus this 120 into minus 0.1 and will be equal to 12, and because this cross product is minus x, we will get 12x. But now at this point we have to understand a very important thing, that is what is the meaning of x. If we are saying torque is or turning moment is in the x direction, what does it mean? If we are saying turning moment is in the x direction, which means turning will be like this. This loop will try to rotate in such a direction like this. It will rotate like this, such that the magnetic field generated by this current, will be, if you see, this is the current flow, magnetic field generated by this current will be in up direction. This up generated magnetic field due to this current flow in the coil will try to align with the existing magnetic field. This is the main thing which we have to understand. Thus, the torque in the x direction means the loop will try to rotate, as we have shown, from y to z, from this y to z, and this loop will try to rotate in such a direction so that the magnetic field generated by the current carrying loop will try to align with the existing magnetic field B. And that's all about this explanation. Thank you.